Welcome back to Money Math. Today is day 8 of our 28 days to FI. We are using the golden ratio, something that is scattered throughout our world, to help peel back any fears or anxieties we already have about math and to reconnect with what interests us, what do we find curious, and learning through that process. I want to remind everyone that this is not evaluative. This is simply me, Sam, a lover of mathematics, trying to bring forth some open, non-judgmental opportunities to explore math, make sense of the world around you, practice communicating using mathematical precision, whether it's in vocab or using statistics and numbers and values and measurements, so welcome everyone. Really want to emphasize this is not evaluative. This is just a unique opportunity to bring more happiness and creativity to our lives using mathematics. So let's get started with an activator. For today, for our pitch day, day 8, we want to know about the words angle, point, center, tangent, secant, circumference, radius. So this is a new set of vocab words, and we're going to connect these very new words to the words we already have a foundational understanding about. Angle, point, center, tangent, circumference, and radius. These are our new words. How do they connect to scale drawing, unit of measure, proportion, scale factor, ratio, value, irrational, rational, numeric expression? So those are all the words that we've really explored with so far. The activator is asking you to identify some points on the coordinate plane and then form angles and estimate their angle measures. So that's a pretty loaded activator. What I'm encouraging you to do is look at this coordinate plane I created with a photograph of the pine cone I'm using for my creative expression for this entire journey. Okay, so here's the pine cone that I hope to paint, and please stay tuned for a supplemental video today about actually taking what we learned yesterday for scale drawing and putting it onto my canvas. So here is my canvas where I'm starting my painting about my pine cone. And yesterday I had to share, day 7 I had to share. So I shared to my husband my plan. I said, I'm really thinking about keeping it with just 2 of the spirals and not tiling the whole canvas with all of the scales of the pine cone, and he thought that was a good idea. So I shared and I listened to his idea. Listening and sharing was yesterday, day 7. Okay, so check out the supplemental video to see the process of putting an image from a 3-dimensional object, okay, taking that image and trying to create a scale proportional drawing on a canvas before I make a painting. Alright, so we have 6 viewers. I always want to give some time for people to log in, for you to text your buddy, Money Math is on! Let's do the journey together! Seriously, you need people to talk to about this. You may not be inspired by a pine cone, but how can you incorporate Phi into a game that you want to make up with your brothers and sisters and play a game jumping on furniture? Just kidding, don't jump on your furniture. But the point is, you need people to talk to, and age doesn't matter. Nothing matters. There are no walls between us humans talking about math, and I really want to encourage you all seriously to accept talking to anybody who can really speak, even if they're just learning to speak. My dear mentor and friend Jenny got this ABCs of Mathematics book for my less than 1-year-old daughter, and boom, there's the golden ratio, and hypotenuse, two very interesting words that we have already looked at. So please, please, please find someone to speak to about the things you've discovered. It's so important to communicate about math. There's only so many pathways we can access in our own brains by ourselves. Okay, so this week our huge focus is sharing, pitching, collaborating. We are talking about math. All right, so our activator. How can we find some coordinate points that relate to this image? I created this image in canva.com. It's a really great free resource that you can use to manipulate and overlay images, use transparency. They have a free library you can access, so I encourage you all to try canva.com, with parent permission, of course, to maybe use this tool to help you understand mathematics. Okay, so I wish I knew how to add my mouse to the window, but I can't. So what I will do is sort of recreate this coordinate plane here, and this can help us review what coordinate points can do for us in terms of finding phi. Right, so if I have, let me use a darker marker. Right here, I was reviewing the concept of phi. What is phi to our new viewers? Oh. Okay, so you all are getting buffering. Let me, okay. So 1 unit is defined as whatever length you want it to be. So understanding phi, a quick review before we keep diving into the coordinate plane. I know I have new viewers that may not have been with us this entire journey. We want to welcome people to join us as frequently as they feel comfortable. So 1 unit compares to 61.8% of that unit, the same way that the sum of those two lengths compared to the single unit. Okay, so you just see that there's some buffering issues going on. Let's look at the coordinate plane. If I was choosing, okay, we're back. It looks like we're back from without buffering. Good. Okay, so on the coordinate plane we have the x-axis and the y-axis, and in mapping out my pine cone, and then what I can do is bring the PDF back up. But just make it smaller. Okay, so the x-axis, just like x comes before y in the alphabet, x coordinates are listed first, and then y coordinates. So what we can do is plot the points. So we're going to plot the points that seem like a spiral that would be interesting to use. So I'm going to use the spiral that's marked with the blue dots. And if you see that this dot comes straight down and a little to the left of the y-axis, and then I'm going to use right triangles to help me find the next dot. So the next one looks like it's straight on the y-axis, so the x-coordinate of this one will be 0, and I haven't decided what that y value is going to be yet. Okay, this x-coordinate is going to be negative, and the y-coordinate is going to be negative. This y-coordinate is going to be negative. We're going in the negative direction below the origin in the y. So our x, y coordinates, all of these are negative. They're both, the x coordinates for this point are to the left of 0, and the y coordinates for this point are below 0. So we have negative values there. Okay? So I'm going to continue. So I started with the origin. Now the first blue dot has also a black dot inside of it because I see two spirals going on here, and I'm not really sure which one really shows the golden spiral, but I think the one that kind of swoops more is the one I'm focusing on right now. I think that really captures the golden ratio more than the less round curve. Okay, so we're going to swing around, and then I see that it's down a little bit and over, so I'm, again, using that right triangle idea to find my next point, and I'm going to erase this coordinate value and put it over here, and it's 0 and negative something. Okay, so I'm going down a little bit, and then over to the right. I wonder if the relationship between the bases is the golden ratio, if it's 1 to 1.618. Like if the shorter side is 1, would that be 61.8% more than 1? I don't know. Okay, so I'm going to continue up. Now the dots are coming back up again. So if you see the 1, 2, 3, 4th blue dot is coming back up. So it's increasing in the y value while it's still increasing in the x value. Okay, but not by much. I'm going to go up a little bit and over. Okay, and then we go way up. This was sort of a shallow increase. Now we're going a much steeper increase, getting very close to the x-axis again. Okay, so that right triangle is at a much steeper incline, or rate of change. Rate of change, that's a good one. That's something we've heard before. Okay, and now let's keep going. Now we're crossing over the x-axis. We're crossing away from the negative side of x divided by y, right? Not x divided by y, but the x-axis breaks the y-axis at 0. So below the x-axis, we have negative y values. Above the x-axis, we have positive y values. To the left of the y-axis, we have negative x values, and then to the right of the y-axis, we have positive x values, right? So just a quick review of the signage for the coordinate plane. Negative numbers are new to a lot of people. Quick reminder that so many people are joining us on this journey, so you need to really discern what is too much for me. I'm going to kind of ignore Miss Sam or Miss Flynn for the next while she's going on and on about this, and I'm going to focus on maybe plotting some cool spirals or something. So you really need to take from this what works for you, what pushes your understanding, and not necessarily exactly what I'm doing. Feel free to go off on the rabbit hole on anything I'm talking about. Okay, so now we're crossing over from negative to positive y, and it looks like we almost go straight up and then just a smidge over to the left. They almost have the same x value. This one's a little bit greater, that one's a little bit less. Okay, and then another right triangle I'm going to use to get up here. I noticed that this point and that point are almost equidistant, so the final point should be close to here, so then this one needs to be a little bit lower. Right, so using right triangles to help us map out a drawing on a coordinate plane is pretty helpful. Okay, so to our know, understand, do. We want to understand how can I learn more about my scale drawing by using a coordinate plane. So just in the activator, we found some coordinates. We still haven't defined what the values are because on any coordinate plane, it's created by a grid of squares. So we do not have to define one unit as the first tick mark. The first square doesn't have to be 1. We could say that, 4 of these squares equals 1. Or I don't even have to use the grid, and I can say that this value is positive 1 in the y direction, and this is positive 1 in the x. They seemed close enough from distance from 0, right? So we have a unit circle, taking us all the way around the coordinate plane. And if this is positive 1, that's positive 1, then I have negative 1 and negative 1. Okay? And then if that is 1, then from there I can decide what the coordinate points are for the entire situation. Okay, so then this looks like about half of negative 1, so that's probably negative 1 half. Okay, here I am about, I don't know, a tenth in the negative x direction, and then maybe, I don't know, a third or a fourth in the y direction. Okay, so all I'm saying is if you define this to be 1, then this point is 1 and then maybe negative 1/10 in the y direction going down. So over in the x direction is positive 1, down is negative 1/10. Okay, again, here are these right triangles helping us use coordinate points. So this one is negative 1/10 in the x, and then down maybe a fourth way to negative 1. So coordinate planes can help us map something out that's not particularly rectilinear or with a lot of polygonal corners and lines, and we can use it to help us find where different parts of an object are that are occurring in nature, and nature isn't always straight lines and boxes and very rigid. Like, you know, the rooms that we have in our homes are polygonal, meaning they have sides and corners and they're flat and easy to be measured. But a coordinate plane can help us say, oh, where are the coordinates of all these important turning points in my object, and how can that help me map it out? It's like a little map, right? So if you have a tree branch, you can say, oh, I'm going to set the corner of the tree branch at the origin, and you can turn it into any of the 4 quadrants and give it all positive values, or negative x, positive y values, or however you want. And then the coordinate plane can help you find different sort of turning points on your nature object. So it can help you make points and then connect the dots to help you create your actual image. So let's connect the dots for my spiral. Okay, and that's where my spiral ends, because my pine cone does not go beyond that distance. So if I'm setting the radius of my pine cone to be 1, then this is it. This is my picture. This is my pine cone spiral. Okay. Notice this pine cone spiral is different from the one that you're looking at on the PDF enhancement right now. This spiral is the less drastic one. It has a smaller curve. It's not as sharp a curve. It doesn't spin all the way around. So what I like about this one is it kind of reminds me of, you know, unfortunately during hurricane season, like the shape of a hurricane. So I liked this one. So I'm going to investigate a little bit further about where is the phi. And luckily with this image, I can overlay a grid and try to get estimates of the coordinate values between the points and see if I can find phi in any of those ratios. What I would like to do now is touch briefly on secant lines, tangent lines. So if any of you are in high school or interested in calculus, this is a touch into calculus, right? So yes, this is aimed for middle school age, right? That's the aim, but we're going to give some stepping stones for anybody less than middle school, not less than, but just before middle school. And then after middle school, high school, adults, all of it, you're all welcome. Here is a middle school taste of calculus. So what I think, I'll just let it be quiet for a second so you can think. What you need is a piece of paper and a pencil, or you can check out these websites. So I have Desmos graphing calculator up in one of my windows, and I also have GeoGebra. GeoGebra has an entire collection of different ways to look at phi. So here's something we haven't even looked at yet, the golden triangle and spiral. We've only done the golden rectangle, so maybe you're interested in exploring that. Okay, here you can plot points. So if I plotted, the point -1/10, -1/4, like we had for the first point on the spiral that we did, you'll see that it gets plotted, and maybe we can continue to plot the parts of the spiral. So then I had 0, -0.5, enter. Okay, and then what was the next one? I would say maybe 1/3, -0.6. So this is now positive 1/3, and I can do 1 divided by 3, comma, arrow to the right, comma, and then -1.6, we'll say. Okay, so then you can start to see my spiral coming up. So if you don't have paper and pencil and you want to try a graphing technology, we are on Desmos.com, and I love this graphing technology. We can just plot points, okay, and then it starts to come up. So I need a value between 0.5 and 0.6, so I need -0.55, enter. That didn't work. Okay, you can see that that does not continue my spiral, so that's telling me I did something wrong. So my green point, it needs to come before my purple point, and my purple point is too close because 1/4 is less than 1/3. So I need something like, let's try 1/2. Okay, that's better, right? So now my last point on my spiral was like 1, and we said it went down like 1/10, -1/10. Okay, so you can start to see my spiral spiraling out, okay? And I don't know, I'm really enjoying this. I'm going to do another one, but my point is try Desmos or try GeoGebra, because it's a really, really welcoming technology that you can play with without fear of messing up. There's no worries here. So, all right, there we go. So my point is you can plot points just like we were doing and try to create the golden spiral. And the calculus connection I want to make with you all is something called the rate of change. Okay, so in calculus, they would call it the secant line. I originally put tangent line on the no words, but then under further review, I realized that, the secant line is really what we're looking at here. So a secant line is a line that goes through exactly 2 points on a curve, and I'm just quickly sketching my golden spiral back onto my board. Okay, it was a very just quick estimate of what it would be. Okay, and I want to find the average rate of change between the points. So maybe I can find phi in looking at the average rate of change. If not, it's just a helpful way to sketch out a golden spiral on a coordinate plane. That's what I like to do when I'm painting, is like I close an eye and I try to find the angle at which I'm trying to draw. So if the tree branch is like that, I'd literally hold my pencil like that and don't change the angle at all. And then I try to use my pencil at that angle and mark the angle so that I'm proportional with angles. Something we should visit in the future, proportionality with angles. Angles don't change. The size of the lengths change, right? The space, the area, the lengths, they are proportional. But the angles should be congruent. If it's zoomed in or zoomed out, the angle doesn't stay. So that's pretty cool. But anyway, so if I connected these dots, these are like the secant lines on my spiral. Okay? And if I were to draw my spiral, you'll see that it would curve just on the outside of all of these. So it's an average rate of change because on a spiral, the rate of change, the degrees of the spiral is constantly changing. So you want to use secant lines to help you find an average rate of change. Okay, so if we had, let's set this to -1 for these purposes, and I'll say that's -1/2. So we have the point x, -1/2, y, -1. And then here, if this is -1, okay, 1, 2, this is about, I would say, -3, about, and it's on the y-axis. So the y value is -3, and the x value, it didn't veer on the x-axis at all, so the x is still 0. So we can find a single value to represent this line. One single value. That's pretty cool. So what we need to do is figure out how much did y change. I don't know if you guys can hear my dog snoring. I guess she thinks I'm boring. Okay. So from here, that starting point of our spiral, to the next nodule of our spiral, the spiral line goes down 2, which is the same as -2. And that's in the y direction, the vertical change. Okay, so the vertical change is the change in y, okay, and the horizontal change is the change in x. So from here to here, we have a change of +1/2. It's increasing. It's going from left to right. It's increasing in x. The change in x is +1/2. Okay? So we convert that as a ratio. Okay, so it goes +1/2 in the x direction and -2 in the y direction. And in mathematics, we use division as our comparison, right? We're comparing with division by using a ratio or a fraction. Okay, this is also a proportion. So what is the single value? To get a single value of a complex fraction, we want to think about what would the numerator be if the denominator was 1. So let's cross multiply here just as a review of a skill, and we'll use the variable, let's not use x, we'll use the variable m. M is used for rate of change on a straight line. Okay, so -2 times 1 must equal m times 1/2, 1/2 m. Okay, so then we get -2 equals 1/2 m. We want to know what the value of m is, a single value of m, and to do that I want to use the inverse operation and the multiplicative identity of 1/2. 1/2 and m are connected with multiplication. The inverse operation of multiplication is division. Okay, I could divide by 1/2, or I could multiply by 2. That's multiplying by the multiplicative inverse. So 1/2 times 2 gives me the identity of multiplication, which is 1. So that's why it's a multiplicative inverse. So if I divide -2 by 1/2, that's the same as multiplying by 2. So m equals -4. Okay, so the steepness of this line is -4. Okay, we went over 1/2, we went down 2, and the steepness, the rate of change, the average rate of change of our spiral is -4. okay? Because -2 divided by 1/2 is -4. So the value of that single line, the slope, is -4. That's a quick taste of some calculus for our more advanced listeners. This just tells us -4 means that the line is decreasing. It's going down. Okay, this is a 0 increase, no decrease. Positive rate of change or average rate of change is increasing, going up. This one's going down. It's steep, right? If it was exactly 1, it would be at a 45-degree angle to the axes. It's steeper than that, so it's a number greater than 1, which is right. Well, the absolute value of this is greater than 1, and it's decreasing, it's negative, right? So then this would be shallower. This is closer to -1 as a slope. This is slightly above 0 as a slope. This is greater than 1 as a slope. Okay, this one is almost vertical, but it's actually really super steep in the negative direction. Okay, so what would that be? Right, that would be like -100 over 1. Super, super, super steep. Okay, and then less steep, so the number's getting closer to -1. The looks like it's shallow now, that if this was 45 degrees, that's more shallow, so that's probably less than 0, but greater than -1. So here we are, day 8. That was a really, really thorough lesson on coordinate planes, okay? So now you need to pitch your ideas to somebody. That is your homework. Pitch, pitch, pitch. Pitch your homework to somebody, okay? And as a quick number talk, what would you say 12.5 times 5 is? 12.5 times 5. Now, how did you get there? How did you get there? How do I get there? I like to break it up into small, small pieces. So 5 times 10 is 50. 5 times 2 is 10. 50 and 10 is 60. Half of 5 is 2.5, so 62.5. How'd you do it? I challenge you to come up with at least 10 different ways to do that simple fact. Number talks are a wonderful way for you to connect with your family. If you don't know how to pitch your idea to them, pitch some really innovative strategies of doing rather straightforward arithmetic. Number talks. Thanks for tuning in. This was a long one. Thanks for hanging in there. It's a pleasure to be with you all, okay? We really need to reach out and communicate to each other about our ideas. So find someone who is open and non-judgmental to talk about your ideas with. Thank you from the bottom of my heart. See you tomorrow. Tomorrow we collaborate.